So in this video we are going to discuss about high pass RC circuit. Okay. So this circuit is also called as a differentiating circuit. So it consists of a capacitor followed by a resistor. So here you have a input voltage, and this is nothing but the output voltage. And this circuit is used for triggering pulse for multivibrators. So here I can write what is V naught. V naught of t is equal to R into VA of t divided by R plus 1 divided by SC, because applying the voltage divider rule. So what is V naught of t divided by VA of t? It is equal to RSC divided by RSC plus 1. A naught of S. Okay, so if I substitute V naught of t divided by VA of S, I can write it as H of S. Okay, so transfer function of output divided by input, right? Okay, so in other words, I can write V naught of t is equal to the I of t into R. Okay, I of t is a current that is flowing in the circuit. So I of t I can write it as dq by dt, right? Dq by dt. Q I can write it as C dV of t divided by dt. So I substitute this, you will get V naught of t is equal to RC into d VA of t divided by dt. So you can see RC is a time constant and t also time constant, both will cancel out, and output voltage is a differentiation of the input voltage. Okay, so from this I can tell this is a differentiating circuit. Now let us come to this point. So if I substitute H of F, okay, so I will get this, I can write it as R of j omega C divided by j omega C plus 1. So I can write instead of omega I can write 2 pi F, right? Okay, so I can write H of F is equal to, so you divide the both term by 1 divided by both term by j 2 pi r 2 pi of RC. You will get 1 divided by 1 plus 1 divided by j 2 pi f RC. Okay, so you can write Fn F L is equal to 1 divided by 2 pi RC. So you can write 1 divided by 1 plus 1 divided by j TFL divided by F. Okay, so if I multiply both term by j, you will get 1 divided by 1 minus j FL by F. So if I take the magnitude of this function, I will get 1 plus FL divided by F square. So this is the magnitude value. So if I take the phase value, phase is equal to minus tan inverse of minus, since it is in the denominator, we'll get minus of minus FL divided by F, right? So we'll get tan inverse of FL by F. This is the phase value. Okay. So at FL is equal to F, if I substitute this formula, I will get H of F is equal to 1 divided by root 2, right? And in this formula, in this phase formula, I will get my tan inverse of 1. So tan inverse of 1 is nothing but 45 degree, right?
Thanks.
So if I draw the magnitude and phase curve, I will get H of F is equal to 1, and it will reduce the value, that is at 0.707. This is nothing but 0.707. Okay, at 0.707 you will get F is equal to FL. Okay, this is about the magnitude, and if I draw for the phase, that is phi, at 90 degree, it started to, you will get like this. So at FL, at F is equal to FL, you will get 45 degree. So now let us discuss what happens when VA of t. Okay, VA of t is equal to V at t is greater than or equal to 0. Okay, so it is nothing but step function. Okay, so VA of t is V when t is equal to t greater than 0. So it is nothing but a step function. So if I get the step function, what will be my out? So V naught of t is equal to V of final value plus V of 0 minus V of infinity into e power minus t divided by RC. Okay, so what is the initial value? So initial value is nothing but V, and the final value is, it goes to 0 because I'm integrating, differentiating this one. Okay, so initial values, it will goes to 0, and of the final values, it goes to 0. In the initial values, V. So why it is at V naught is equal to V0 of 0 is equal to V means, so initially whenever the step input is given, there is a sudden change in the input, right? At t is equal to 0, the input suddenly goes to V, right? So VA of t is equal to, that is VA of 0 is equal to V, right? It suddenly changes. So the capacitance is short circuited. So if it is short circuited means whatever the input voltage will appear at the output. So V naught of 0 is equal to V. Okay, this is the initial case. When the capacitance full is charged. Okay, so when the capacitance is fully charged. Okay, so fully charged, when it happens, when V naught of infinity. So when it is fully charged, it is open circuited. Therefore, my output goes to 0. Okay, so you substitute here. So if you substitute here this equation, so you'll get V of e power minus t divided by R. So this circuit will look like this. Okay, V naught of t. Initially it is V and it is start to decrease. So if I look at the capacitance, so initially whenever the during the high frequency, what will happen during the high frequency? The XC value is very low, right? Very low. And therefore, the input will appear at the output. Okay. So V naught of this is nothing but VA of t. Okay, it is short circuited, right? It's very low, therefore it is short circuit. Okay, so at low frequency, this XC value is very high, therefore it is open circuited. So the low frequency signal will not be appear in the output. So that is why it is called as a high pass filter. Okay. So now let us discuss about tilt or sag. Okay. I told you whenever the pulse signal is whenever the step signal is in the input, you will get the output like this, right? V naught of t. So it start to decrease. Let me assume instead of decreasing like this, it is decreasing like this. Okay, at t is equal to Tp. Okay, if I assume this is V and this point is V dash. Okay, so what is my output? Output voltage V naught of t is equal to V dash, right? So what is my V dash? V dash value I know it is V into e power minus t divided by Tp divided by Rc, right? From the previous equation. So what is tilt means? Tilt means original value minus the final value divided by V into 100. Okay, it is a percentage tilt. Okay, so you substitute this value V minus V dash. V dash value is V minus. Okay, this I can write it as V of 1 minus Tp divided by Rc, right? And it will goes on, right? So if I substitute this value, I'll get so here if I take Vv common, I will get Tp divided by Rc by 100. Okay, so if I assume this is my T, okay, if I assume this is my T and T is equal to 2 times the Tp. So if I substitute here, I will get T divided by 2 Rc into 100. So this is my percentage tilt. Okay, so this I can write it further as 1 divided by 2 FRC into 100. Okay. So second write it further as pi F1 divided by F into 100, where F1 is equal to 1 divided by 2 pi RC. Okay. So let me assume let me tell you what is duty cycle. So duty cycle D is equal to T on divided by total time. So into 100%. So the second write it as T on divided by T is nothing but T on plus T off.